Welcome to this chapter on speed and graph. This is our lesson number 4 on chapter motion. Before this chapter, we have already understood the distance time graph in two parts. Then we have understood acceleration. This is your lesson number 4, which builds up on the fundamentals of the previous 3 chapters. If you have not gone through the previous chapters, you may go through them if you want to really understand this chapter well. Speed time graph. What is a speed time graph? Like the distance time graph, the speed time graph is also a graph with the y-axis and the x-axis, with the speed on the y-axis and time on the x-axis. Alright, so this is your speed time graph. Let us see a sample speed time graph here to understand how it looks like. So the graph that you see here, it is a speed time graph. Why? If you see, you have your speed here on the y-axis and time on the x-axis. When you look at the speed time graph, it gives you readily some information by just having a look at it, right? So that's the whole purpose of actually drawing a graph. If you have a data in form of a table, you are reading a lot of numbers here and there in the tables, in the various columns in the table, doesn't make much sense, right? But if you are drawing a graph, you see a pictorial representation of it, and it is more easy for you to decipher information. So what information can we derive here from this graph? One of the few pieces of information that we can readily understand when we look at the graph are listed here. The car moves at a constant speed of 18 meters per second for the first 2 seconds. I am on the first bullet point. Let us see. Between 16 and 20, you have your 18 here. So the speed was 18 meters per second here, and it was constant. It was constant for the first 2 seconds. If you see, 0 to 2 seconds, the speed was constant. It wasn't changing. And the speed decreased. I am on the second point now. The speed decreased from 18, this is the point that they are talking about, to 0 in the next 10 seconds. Which is the next 10 seconds they are talking about? They are talking from 2 to 12. 12 minus 2, 10 seconds. 12 minus 2 is 10. This is the 10 seconds that they are talking about. The speed went all the way from 18 at this point to 0 at this point, right? Speed was 18 here, speed is 0 here. Do you look at the y coordinate if you want to find out the speed? At time 2, which is the x coordinate, 2 is the x coordinate, the speed was 18. At time 12, which is the x coordinate, the speed was 0, right? The third point, the car speed was 0 after 12 seconds. After the 12 second, let me clear this graph. So after the 12th second, what do you see? The speed was maintained at 0. It was touching the y-axis. Any line which is on the x-axis has a y-coordinate of 0. Y-coordinate gives you the speed. So the speed after the 12th second, it is a flat line. So for all the values of the time here, the speed is 0. So that's how you decipher, you understand a speed time graph. We'll be working out more examples as we proceed through this video. But let us first understand some basics. What is gradient? What is gradient? This is something that we have already discussed when we were talking about distance time graph. But let us understand it here again. Gradient is what? It is change in y over the change in x. For example, if you are given a line, you see a green line here. If you are dividing the change in the y as the line rises from one point to another change in y over the change in x, it gives you the gradient. But if this graph was a speed time graph, on the y-axis if you have speed, and on the x-axis if you have time. So what is the change in x? What is the change in y? Change in y is change in speed. So the whole numerator becomes change in speed, right? Change in y is same as change in speed, because now we are talking about a speed time graph. The numerator becomes change in speed and the denominator becomes the change in x, which is change in time. Change in speed over the change in time. Change in speed over the time taken for this change to happen. And this we know is the formula for acceleration. Acceleration is what? Acceleration, if you remember, it is the change in velocity over the time taken. If you have not gone through the video on acceleration, please go through it if you want to understand this particular section nicely. Change in velocity over the time taken is same as acceleration. And what is velocity? Velocity is nothing but the speed. When we talk about speed in one direction, we are talking about the velocity, right? So what do we understand from here? Gradient is the same as acceleration. Gradient is same as acceleration when your graph is a speed time graph. When your graph is a speed time graph and you can find the gradient anywhere, the gradient gives you the acceleration. Gradient is change in y over change in x. Change in y is same as change in velocity over the time taken for this change. And change in velocity over the time taken for this change we know as the acceleration. Simple, right? So it's your notes time. Take down some notes, take out your pen, paper. Okay, so what is the notes? Acceleration is the gradient of the speed time graph. If it is a distance time graph, the gradient gives the speed. If it is a speed time graph, the gradient gives the acceleration. Please do remember this very important point, right? I'll say it again. If it is a distance time graph, the gradient gives the speed. If it is a speed time graph, the gradient gives you the acceleration, and not so difficult to remember. If you know the formula, if you have an understanding of the formula for the gradient, which is change in y over change in x, you need not memorize these things. You can automatically interpret it every time. Distance over time is speed. Therefore, the gradient of a distance time graph is speed. Speed over time, or the change in velocity over the time taken, is your acceleration. Therefore, the gradient of a speed time graph is your acceleration. Simple to understand. You'll not forget if you understand the reasoning, the thoughts behind it. Right? So let's move on. Now that we understand that the acceleration, let me change the pen color. Now that we understand that the acceleration is same as the gradient, let us solve this example. We have to find what is the acceleration in the part 1 of the graph, what is the acceleration in part 2 of the graph, and what is the acceleration in part 3 of the graph, right? So acceleration is same as gradient. The formula, the symbol for gradient is m. So what is the gradient in the part 1 of the graph? It is a flat line. A flat line has a gradient of 0, right? So the acceleration in the part 1 is 0, simple. What is the acceleration in the part 2 of the graph? Again, the gradient. Acceleration is the gradient. Let us take any 2 points on the graph, point A and point B. Let us name the points point A and point B. Let us write down the coordinates of A. Okay, what is the x value? 2, comma, this is your 18, 2, comma, 18. What are the coordinates of B? B is 12, comma, 0, right? Let us call one of them as x1, y1 and the other one as x2, y2. Let us now use the formula for the gradient. What is the formula for the gradient of a straight line? Simple, y2 minus y1 over x2 minus x1. This is what we understand from our coordinate geometry in maths, or you can do change in y over the change in x. So y2 is y2, 0. y2 is 0. y1 is 18 minus 18. What is x2? 12 minus x1, 2. Minus 18 over 10. So how much is the acceleration? Minus 1.8 meters per second square. I forgot to mention the unit here. Meters per second square, right? The acceleration is a negative number. If you go to the chapter on acceleration, you'll understand that you do not have to get scared when you see a minus sign and just vanish it away, right? No, please don't do that. Please don't do that, right? Because negative sign has a meaning to it. Let us understand what is the meaning here. The negative sign means it is a deceleration. Deceleration means the time is increasing. The time from 2 to 4 to 6 to 8 to 10, the time is moving on, but what is happening to the speed? Speed is going down. Look at the speed. Speed is going down. The speed is going down on the y-axis. You are decreasing in your speed. Decreasing in the speed means negative acceleration, or there is a deceleration. Negative sign has a value to it. Do not skip it. Do not get scared of it. This is my request to you again and again. So acceleration is minus 8 meters per second square, or you can say that the deceleration is deceleration is 1.8 meters per second square. So I've explained all these things, how to write the acceleration, deceleration in the previous topic, in the previous lesson on acceleration, right? Let's come to the third part of the graph. In the third part of the graph becomes a straight line, flat line. Again, let me use a different color pen because it is okay. The last section, again a flat line, acceleration, which is same as your gradient. Acceleration is same as your gradient, as you see here. So therefore, gradient is 0, acceleration is 0 meters per second square. So that's how you solve questions or speed time graph, where you have to calculate the acceleration from a speed time graph. Alright, now there are 3 cases of the speed time graph. Let's go through them one by one. We'll go through case 1 first. The speed time graph with constant speed. So you're going to plot a speed time graph, right, where the speed is constant. So how would a speed time graph with a constant speed look like? It would look like something like this, a horizontal line. Why? The time value is increasing with every passing next point. The time value is increasing, right? If you move from this point to this point, this point to this point, the time value is increasing, right? But is the speed value increasing? Speed value is static. Say that the speed here is 5 meters per second. This was a 1, 2, 3, 4 and 5. The speed is fixed as at 5 meters per second, whereas the time is moving on. Time is moving on. Speed is constant. You're maintaining a speed for all the values of time. Right? So what is the acceleration? Are you increasing your speed? If you are not increasing your speed, you're not accelerating. You're moving at a constant speed. So acceleration is 0. Acceleration is 0. We can work it out and check it as well, right? Let us calculate the gradient here. The gradient here. What is the gradient? Let us take any 2 points. Let us take point A, point B. Say that the time value at point A is 2. Time value at point B is 4. So what are the coordinates here? 2 and 5. The coordinate here is 4 and 5. So what is the gradient? Change in y, y2 minus y1 over x2 minus x1. Let us call this x1, y1, x2, y2. You can take any one of them as x1, y1 and the other one as x2, y2, doesn't matter. Right? y2, y1, both are 5, 5 minus 5 and 4 minus 2. So 0 divided by any number is always 0. The gradient is coming out to be 0. So what can you say about the acceleration? Acceleration is 0. Sorry, acceleration is, I'm sorry. So what can you say about the acceleration? Acceleration is also 0. So this is same as gradient. Acceleration and gradient, they are the same. Acceleration is 0, right? Let us understand the second point now. Speed time graph with inclined straight line. So if you have your speed time graph where it is coming out to be a inclined straight line. So if your speed time graph comes out something like this, or maybe like this, or like this, or like this, so many ways possible, right? Straight line. If your speed time graph, what it means, it is a straight line. Inclined means it is not horizontal. We are talking about any other straight line. It can be like this also, right? Any other straight line. A straight line has a constant gradient. This is also something that you learn from your maths. A straight line has a constant gradient. So the acceleration is constant. This point is easy to understand. A straight line has a constant gradient all throughout. So therefore a straight line represents an acceleration which is constant. No matter what the time is, you're accelerating at the same rate. Right? Now let us understand the third point. Speed time graph with curve. Two kinds of curves are possible. Upward curve. How an upward curve would look like? Something like this. Downward curve. Let me use a different color to show the downward curve. A downward curve would look something like this. Right? This is your downward curve, downward curve, downward curve, downward curve. Similarly, upward curve, different ways possible. Upward curve, right? Right? So let us understand one by one. If the curve is upward, an upward curve. Let's focus here on an upward curve. Let me draw an upward curve here. So what is happening? In a speed time graph, the gradient is your acceleration. Acceleration, right? Gradient is your acceleration. Let us find the gradient at various points. Point A, point B, point C. Since this is a curve, if you have to find a gradient on a point in a curve, you have to draw a tangent at that point. So let's draw a tangent at point A, tangent at point B, tangent at point C. Look at the tangents. Tangent at point A is flat, smaller gradient. Time passed by, you reach point B. The tangent is more inclined, more steep. Gradient has increased. Point C, gradient is more standing, more gradient. So with every passing time on the x-axis, this is time for A, time for B, and time for C. With every passing time, the gradient is increasing. Gradient is increasing means acceleration is increasing. Why? Acceleration is gradient, right? So if it is an upward going curve, it represents increasing acceleration. It represents increasing acceleration. Similarly, we can think about a downward going curve. A downward going curve. Let's draw a curve which is going downwards. Let's pick up 2 points, A and B. Let's draw the tangents at point A and B. Like this. And it has to touch B. Say that it is touching B, right? What is happening to the tangent? Tangent is becoming less steeper. As the time is moving on, the tangent is becoming less steeper. The gradient of the tangent gives you the acceleration. Gradient is the acceleration. Tangents going down, the graph becoming less steeper. What does it mean? Decreasing acceleration. A downward curve in a speed time graph, decreasing acceleration. An upward curve in a speed time graph is increasing acceleration. Simple, easy to understand, right? If you have any further questions or doubt, please type in the chat box. I'll clarify each one of them. Okay, so some notes for the students on the speed time graph. On a speed time graph, the gradient of the line is numerically equal to, yes, you're right, the gradient is equal to the acceleration. Right, now this is a new point. On a speed time graph, the area under the line is equal to the, many of you all might know it already, it is equal to the distance traveled. Let's solve a few questions on this now, right? So I am going to show you a distance time graph here, and you have to find the distance traveled. If you are given a velocity time graph or a speed time graph, the techniques used in both the graphs are almost similar, 90% similar. So do not get worried. Same fundamentals you'll use here as well. So you have to find the distance traveled by the car from 0 to 10 seconds. 0 to 10. Distance means you have to find the area under the graph from 0 to 10. So which is the portion of the graph we are talking about? 0 to 10. So what is the area of the graph under 0 to 10? That's the area of this rectangle, which is 20 times 10, 200. 200 meters. Next question. What is the distance traveled by the car from 10 to 15? So now we are talking about 10 to 15. So which is the portion of the graph lines we have to focus on? We have to focus on this line, which is a triangle. Now we use the formula of the area of a triangle, because the shape which is coming under the graph line is a triangle, right? So what is the formula for the area of the triangle? Half base height. So half, what is the base? 5. Height is 20. So what should be the answer? 50. Let's see. 50 meters. There's one more question here. What is the total distance traveled by the car? Total distance means starting from the time 0 till the final point. It is the total area under the graph. Now they are talking about this total area. So what do you have to do? Simple. You have to add both the answers that you got in the previous 2 questions, and that will give you your answer for the last question, which is 250 meters. Right? If you want to go through the theory that we understood in this question, you can rewind the video and go through it again. So here we have a summary on the speed time graph. Pause for a moment, solve it, come back and play the video again. Alright. So here in the first graph, you have an inclined straight line, a speed time graph which is an inclined straight line. What does it represent? It is a positive slope. It is speeding up. That means it is accelerating, right? It is accelerating. Second line, a flat line, 0 acceleration, no acceleration, 0 slope, no gradient, 0 slope, constant speed, no acceleration. A speed time graph which is going down, it is a negative slope. Negative slope. Negative slope means negative acceleration. Negative acceleration is deceleration, slowing down, slowing down. All right. Now we have finished the distance time graph. We have understood acceleration as well, and we have finished speed time graph as well. The next video will be about solve examination type of questions, and we'll solve it in the next video. If you want to directly move on to the next chapter will be on free fall. Or else if you want to get very well versed with the theory that you have learned so far, you can go to the video which is on solving the exam style questions on the topics that we have learned so far. Alright, thank you so much.